Okay, bonjour, messieurs, dames. This is my friend Ed Merckx. My name is Eike Stepper. We hope you enjoyed the small show, and now it gets real business. So, do we have the slides? Perfect. So, the first minutes I would like to show you a little bit what problem we are trying to solve with Eclipse. We don't have so many slides. We hope they are interesting. We'll have a bigger demo part after that, and then, of course, the exercises that we announced. So imagine there's a project, let's say in a company, and the source code of this technology is in a source code repository. So then a new developer comes into this project and wants to work on the source code. He sees it is a Git repository, and he's supposed to install Eclipse. So he installs Eclipse, and when he starts it the first time, the workspace is empty. So how does he get the source code into the workspace? Well, he sees it's a Git repository, so he installs some Git tooling, a bunch of plugins into the IDE. Then he has read the Git tooling documentation and sees he must do certain configuration in his workspace. So he's doing that, and after that he can check out the source code. But of course he can't start immediately. He read the setup documentation of the project and hoped that it is not outdated. So he has to do a bunch more configuration in the workspace. For example, set the formatter profiles, that the source code is formatted correctly, and so on. Then the setup guide tells him to install a diagram editor, because the source files in here, they contain, let's say, diagrams, and you need special plugins to open them and edit them. And these diagram editors, maybe Papyrus, needs more configuration in the workspace. Then he read a special source code generator is needed for this project. So he installs it, configures it, and then he reads he needs to install find bugs. He installs it, configures it in the workspace, and so on. And of course, at this point, he's missing all his personal tools, like his favorite XML editor and so on. So he's installing those plugins, he's configuring them, and at some point he gets a little bit nervous and asks himself, is this the way? The really bad thing is, once he's done all this and he goes to the next project and wants to work on the next software, then he can do the same thing again. And again. So this is a situation you probably know, and we know it for our Eclipse projects for many years. So we have thought, what can we do? And what are the really important concepts that we want to automate? And we've come up with 3 places that need configuration, or where Eclipse likes to store configuration. That is the installation itself. You can think of it as the Eclipse folder where Eclipse is installed, the workspace you're working on, and one thing that Eclipse itself doesn't use a lot, that is the user scope or the user home folder, the place where you would like to say once, this is my favorite XML editor and I configure it like this, and I don't want to do it in each workspace. So these are the 3 important places. How do we use them? The installation, by the way, these are really files that exist in the installation in the workspace or in your user home folder when you use Oomph. And typically, they contain so-called setup tasks. That is the major concept in Oomph that is used to configure your development environment. You can put the setup tasks directly in these files, but for the most typical combinations, for example, configure the IDE exactly like a download from the downloads page at Eclipse. We have so-called product and project catalogs, and you see that down here. This is a project catalog, and we maintain that at Eclipse. You see products listed here, and each of these products already contains a number of setup tasks. So you don't have to write them all into these files. You can just point to one of these products, and the respective setup tasks are associated with the installation. The same happens on the right side. That are project catalogs that we maintain at Eclipse. You will later see that you can do them yourself too. And you can point to 0, 1, or even more projects and link your environment to the setup tasks that they contain. The third scope, here you see that all of these choices induce setup tasks. Yeah? These are P2 director tasks. We will see the details later that install software. These are configuration preference tasks. There you see that is a project import task that once the repository is cloned, imports the project into the workspace. And finally, we have the user setup over there. And there you have typically tasks like configure my key bindings, associate file endings with editors. So everything that is not project specific, but really specific to you. Things that you want in all your workspaces. So Oomph has a setup engine that collects all the setup tasks from these various places here, puts them in a specific order that is determined by priorities that are hard-coded into the tasks. But these models that we will see later, that you can also specify dependencies. This task should run before that task, and so on. The engine takes them, sorts the tasks, and then finds that some of them excuse me, need additional information. For example, where on my disk should Oomph install the Eclipse IDE? These are things Oomph derives from the tasks, and it creates extra variable tasks, and it asks you, it pops up a dialog, you will see that in the demo. You can enter these variables. The results are then stored in these files, at least in most of the cases, so that you have to do it only once. An example, when you use a task to configure a JDK for Java development, this task will ask you, where is that JDK? And of course, it is always there, no matter in what workspace you use it. So Oomph will ask you only once, because after the first question, the result is stored in one of these files. So then these tasks will be executed, and in the end, you will have an Eclipse IDE with all the tools installed, with your personal preferences set, with the repositories cloned, with the projects imported, and so on, and you can directly start to develop. That's basically it. Before I hand over to Ed, that he shows it in action, I would like to go into more detail for two specific tasks, probably the two most important ones. The first one is our P2 director task that installs software into your IDE. And for that, I think it is important to understand a little bit, at least, how P2 works. Question for you. Who of you does not know what P2 is and how it works? Please quickly raise your hand. Yeah, I expected that. I guess that some of you who didn't raise your hand are still surprised about the underlying details. I don't explain every detail, only the ones that are relevant for Oomph. The central concept of P2 is an installable unit. It's mostly called an IU. An IU is identified by an identifier and a version, a fixed version. let's say 1.1.0 dot and a build qualifier, so something very specific. And the content of the IU is supposed to be the same no matter from where you get it. When you see that ID version combination, you can be sure it has a specific content. Of course, there are thousands and probably millions of IUs out there in the world that you can use, and they have relations between each others. And you could think they depend on each other through their ID and version, but that is not true. Each IU can specify so-called capabilities. And a capability is a virtual thing. It is really this triple that you see there. It's a namespace and a name, a little bit like an ID, and again, a version. But it can be what you want. If you create an IU, you can say it has this capability, that, and that. It's up to you.
So a concrete example of a Java plugin will have capabilities for the exported packages. So it makes available these specific packages, and other things can have package imports to plug into those types of things.
Yeah, we come to the imports, of course, a little bit later. So each Java package in a Java plugin is a declared capability of that IU. And there is one special capability that each IU has, that is the so-called self-capability. And that enables you to let an IU depend on another IU directly, because each IU declares its own ID and version as a capability in this namespace. That is why you can say, I want an IU, and you get the IU with that self-capability. So how do you say an IU wants some other capability? That is done with requirements. And I had the feeling this looks a little bit like this typical component design, where a component has interfaces and it has requirements. I think it's very similar. But keep in mind, an IU is just metadata. In the end, it's a block of XML or something like that. Yeah? So these requirements are similar to the capabilities, of course, because they require capabilities. Differences are, for example, they have a range of versions, while the capability has an exact version. Requirements can be optional. That means if it is found, it is installed. If not, it doesn't matter. If it's not optional, the installation will fail if it's not there. Greediness is not so well known. That has only a meaning if the IU is optional. If it's optional and greedy, it's tried to be installed. If it's not greedy, it will not be installed, even if it's found. But other IUs could pull it in, and then this one could use it. Okay, so now we understand what one IU is, but where are they? How can you work with them? Typically, let's say you develop an IU. Oh yeah, I forgot. Of course, then they are wired in this dependency network here. So once you have an IU, you have developed it, you deploy them, or you say you publish them into a P2 repository. That is what formerly these Eclipse update sites were called. But P2 is way more flexible, and it's a replacement of that. So now your IU is somewhere in the internet in such a repository. How does it get back to another computer? You have to do an installation. And for this installation always begins by creating a new P2 profile. We'll see later where that is on your disk. Then P2 does a so-called profile change request. And there you can say, install an IU with this ID and this version. Then it finds that in a given repository. It identifies its dependencies and will then install it into the profile. But before I show that, please note that this here is a capability. And this requirement is, for example, by a version range, you remember. And this here is really not a version range. What I would like to point out is the initial request here is different from all the others within the repository. It's not so flexible as the others. You will see later that we enhanced that in Oomph so that they are all flexible. So, and then these installable units will be installed into the profile. And of course, each IU carries the physical artifacts with them. So in the end, you will end up with a list of plugins and features and binary units and so on. How does that look like on your disk? What's needed to make that all happen? The most central concept in P2 is a P2 agent. That is a folder on your disk. Typically, it's called P2. And it has a number of internal folders. Normally, you don't look so much into them. Just to name a few, there's a cache folder where P2 caches all the metadata. Yeah, metadata is in these repositories. So if you have a problem, maybe, I don't know, there was a network problem or so, you want to get rid of that cached data, you can just delete that folder or empty it. The most important one, I think, in the agent is the profile registry. Each agent can maintain a large number of profiles. In most cases, it starts with exactly one, a default profile for an installation. The second location on disk is a so-called bundle pool. Even if you haven't heard that term, you will later learn you have used them already. So a bundle pool really contains the physical artifacts, features, plugins, and a list of them in this artifacts XML descriptor. And what you certainly know is the resulting installation. The installation is the executables, or the launcher, the INI of the launcher. And this configuration folder, very important, is this config INI file, because that links together the parts that you see here. The config INI points back to the profile that determines this installation. The profile, in turn, points back to the installation, so they really belong together. In many cases, you can't move them. That's a small detail. And very important, each profile points to a bundle pool that has the physical artifacts of the installation. So who of you knew that? Who has used that already? It's a smaller number. That's what I suspected. But if you have a look, if you combine these three locations into one, then it looks more familiar, right? So this familiar Eclipse installation that you know, this is just a special case of a very flexible P2 concept. And if I go back, these bundle pools, we will use them a lot in Oomph because we just move all the physical artifacts that are the same in all installations into this single place and keep the installations small, like here. We will see that in the demo then. So, and the last point, or the last topic, oh no, sorry. I promised to tell you our enhancements on top of P2. So, we have in Oomph, we have an agent manager. That means we know all the agents and all the bundle pools on your machine. That is quite important to be able to do things like garbage collection and so on. Yeah, we have an agent analyzer that detects damage in the bundle pools. That's very important. You can imagine when you move all the plugins out of your installation into a shared bundle pool and that gets damaged, then all of a sudden your 20 installations stop to work. So you need something to analyze and repair the bundle pools. And we have that in Oomph. Ed will demo that later. We created a lazy profile registry because in the previous slides I mentioned P2 can store hundreds of profiles in the profile registry. That is true, but it loads them all, even if you start only one installation. And typically you don't have many profiles, but with Oomph you will probably get more and more of those. And that can take minutes. So we developed a better profile registry. Then we store, we call it a profile definition. Normally a profile only contains a list of IUs, the ones you have installed. That means the profile itself doesn't know why they are there. It doesn't know the original request that installed them into the profile. And we add that information. The advantage is you can later, from the outside, re-resolve the profile, and you know why it is like it is. I mentioned that the entry into this IU network is an ID and a version, other than the dependencies between the IUs. And we have changed that. With Oomph, you can require or you can install Java packages. You can't do that normally with P2. You can specify Java version ranges, and you can specify optional dependencies or optional software and so on. Very important for us was to have a better transport layer on top of P2s, one that does better caching, so it gets quicker. We support an offline mode. We will use that here during the tutorial. That means if all the metadata is cached, with Oomph you can install installations or eclipses without doing network access. So now the last topic I would like to show some slides about is the target platform. So far we have seen that you can use P2 to install products, Eclipse installations. But your target platform, in case you develop plugins yourself, that is a hairy thing typically. The target platform, who of you has used a target platform already? Most, I guess. A few not. Maybe it's interesting for you. You will maybe see you can use a target platform even if you don't develop plugins. If you're interested in that, maybe contact us after the show and we show you what the benefits are and how to do that. So a target platform is not a thing that exists in the thin air just by itself. The workspace needs it. The projects in the workspace need the target platform. That is often a little bit forgotten. But in Oomph, we really focus on that thing because the workspace determines what must be in the target platform. Normally, it is not determined by the workspace, but by a file where a so-called .target file where you write, I want that IU and that IU and that plugin in my target platform. This .target file, most of you know it, I guess, contains stuff like that. You point to the P2 repositories, and then you list the plugins you want in your target platform. And either you specify very exact versions here, or you say, I don't care at all. But you can't say, I want the Eclipse platform in the target platform with versions between 3 and 4. That is just not possible. So you can't use version ranges. Another problem is it's absolutely not fault tolerant. If you make a mistake, you are totally hosed. Your workspace is a sea of red errors and nothing works anymore.
And be careful when you double click the .target file because it will resolve right away and destroy your target platform.
Yeah, exactly. It is not workspace. Was there a question? Okay, so it is not workspace aware. Yeah? It's you. You have to define what you write there. It doesn't look at your workspace and says, you have plugins there and they need A, B, and C, and so I put that in the target platform. It's not lazy, that is what Ed said. If you open it, it goes to the internet and tries to resolve, and that takes 10 minutes. It, of course, doesn't support an offline mode. You have to be network connected to work with that thing. And, very important, it is not modular. If you go a couple slides back, you remember that with Oomph, you can configure your IDE with multiple of our projects. And each of these projects defines their own target platform. Yeah? But with these .target files, that's not possible. You cannot combine them. Yeah? So the target platform is not modular. So we have developed a layer on top of that makes use of our P2 layer, of course, and PDE. And we call it a target container. Target to focus or to stress that it's modular. This container, it looks like that. We will use that in the exercises too. It's a model, of course. It's a EMF model. And you see this is a target. So one modular part of a target platform. And you can specify features or plugins here. And notice that in this case, this is our own. It's from our own namespace. So this points to one of our top-level features. And the target container is smart enough to look at the sources of this feature, discover the dependencies, discover those dependencies, and just discover what's needed in the target platform. It can do so through these so-called source locators. Yeah, there you tell the target, the sources are here in this git clone, for example. It supports additional binary dependencies, so that are not our own ones. And they can be optional, they can have version ranges, everything that we can do on the P2 layer already. And of course, these not our ones, the binary dependencies, they must come from these repositories, P2 repositories listed here.
An important concept there, often people have multiple .target files because you want target platform for Luna and one for Mars. So that concept's supported here by these named repository groups. So the user, when you install, you get prompted which version of the target platform do you want. You can say Mars or Luna. And so a single definition defines a target platform for multiple different choices, where normally you have multiple .target files and be duplicating the information across them.
So here you see that our target technology integrates nicely and deeply with PDE itself. It is basically a fifth type of target location. Most people only use these software site locations. That is what you see in the .target files. And Oomph's target container is just a new location type. And you see that one such container can contain multiple targets. And when the target platform is to be resolved, they are all merged together and automatically form one target platform for all the involved things. So how does that work? I just said that all the available targets will be merged. Then it identifies the source plugins and features from the source locators in the targets. Then it generates P2 metadata for the source features and plugins.
So it essentially induces a P2 update site directly from your Git clone, as if you built it and published it and produced a P2 update site for it.
And then the requirements that are listed in the targets are resolved against this generated metadata and the configured P2 repositories, the internet P2 repositories.
So you know everything that's in the workspace will have something in the target platform to make it happy. The overall thing is solved and satisfied. You won't get errors that things are missing.
So, and then an interesting aspect is that during this requirement analysis that included your sources and the binary things will be put in the target platform and the source things will be imported into the workspace, because that are the things that you are working on and that need the things in the target platform.
And it also tries to be smart that if you point at your own build site where the binaries for your source have been built and are in binary form. While it resolves, it will not only include projects in your workspace, but it will include binary versions of them in your target platform with the aim that you can close projects in the workspace and the binary solution for them is still available. So for big projects like Papyrus, this becomes important because they have 3,000 projects, and that's a lot of projects to have open in the workspace. So we've tried to design it so you can actually close most of the projects in the workspace and work on just a few, and the binaries are there as well.
Yeah, step 7 is also quite interesting because there can always go something wrong when these dependencies get resolved. Typically, a P2 repo is missing or it has changed and doesn't have the content anymore. So with our target container, we always keep the old state until we know the new one is really functional. So you will not get into the sea of red workspace situation. And that's the theoretical stuff. And now I'll hand over to Ed, and he will demo that. In the meantime, we have some sticks prepared. I guess some of you didn't get the download, so I'll give them around. There's a big zip on it, 2.5 gigabyte or so. Please just copy it to your disk, and then Ed will show you how to use it.
When you're putting it on your disk, create a blank new folder. It doesn't matter where you put it, but unzip the contents into that blank folder. So the structure of the zip looks like this, and it's got these 5 folders in the root. Don't worry about following along while I do this initial demo. I'm going to show you the whole end-to-end scenario, and then I'll go back to the beginning and make sure that you can walk through all of the steps. So one of the things that we did to prepare is we really wanted to not rely on the internet working at our tutorials. So we made sure that the entire scenarios work completely standalone. That's why you have this giant zip file that has a mirror of Mars. So we released Mars early in this room, a couple hours early. The whole Mars repo was there and all the installers. There are different versions of the installers on the zip for all of the different platforms. We have virtual boxes. I really tested this on Linux and Mac. I'm on Windows 64-bit. One interesting thing I wanted to show you is how we made this all work offline. If you look in our INI file, I've hand-built these things locally so the binaries won't be signed and the exe won't be signed. But we have these 2 redirections. One of the things we did fairly recently in the development cycle is the webmaster got upset because all of these setup files are maintained as plain text Git commits, and he was very worried about 100,000 people pulling from our Git server. So we actually have an archiver that walks the whole models and puts them in a zip file. That zip file is normally at this location at Eclipse, but we've told it here, get it locally from this installation that I've redistributed. And I've put some local stuff, our tutorial project I've put in here, so that's not something you'll see online, but you'll see in this example. And you see here, I've redirected everything that's at download Eclipse. Well, in fact, you'll see that in my setup here, specifically the self-update of the installer. I've redirected to a local mirror of that installer. So basically, you have to double-click. One thing I should note too on the Mac, I think on the Mac, it will just run without changing the permission bits. If you're on Linux, you have to go and change the execute permission bit on the installer for it to run. Windows has no such concept. No, I think it's better that I walk through the whole scenario because it's just too slow moving otherwise, and better once I finish, I'll go back to the start and make sure that people are following along. So when it first comes up, it'll probably come up in this simple mode. I'll walk through the steps again later, but in the advanced mode, we have a lot more flexibility. We can install projects, and yeah, the UI is a little bit more complicated. But if you look at the basic thing here, Aiko already showed this, that we have this concept of a product catalog that contains product definitions. So if you look at this list here, these are sort of the familiar packages that you download, the zip files that you're familiar with downloading. So for this tutorial, I'll pick the committers package. I'm making sure that it's the Mars version that I'm installing. We have some very nice features in Oomph that we can index all of the JVMs that are on your system. We look in the system registry, the path, and your home, and so on. So we know all the Javas that you have on your system. If there's one sort of in your own secret, non-standard locations, you can browse and add them to here. But you see, I have quite a few JREs on my system. One of them is marked current. It's the one that was on the path and found by default when I was running the installer itself. So you can see that here I have a choice of all of the different JVMs, and you can see the ones that are grayed out are not the right bitness or not a high enough version for the product that I'm installing. So before you even get as far as installing, it's going to prompt you, make sure that you have a JVM that's going to work with that installation. Aika also mentioned this bundle pool analysis. There will be a default bundle pool location suggested for you, but you can create your own and decide where they're stored. For me, that was really important. My C drive is very small and my D drive is very big, and by default, it ends up on my C drive. So that was the first thing I did, and the first thing I insisted that we'd be able to configure this, because when my C drive runs out of space, my computer stops working. And we can do things like analysis of this bundle pool, and I have quite a few profiles and quite a few artifacts. And you can use this to manage. You can see it's checking which ones are damaged, so it's looking at all the jars, making sure there's a decent manifest in those things. And I can use this thing to do garbage collection and so on. And clean up things like unused profile. You see, I've been playing a lot on tutorial preparation, so I have a lot of profiles where I actually deleted the corresponding installation, and so I could clean those profiles up. So it's pretty simple to start. You pick a product, make sure the version is right, the other defaults will be appropriate. For this tutorial example, if you're using this installation, you'll see at the beginning there's an Oomph tutorial project definition. So we're using Oomph here to set up your tutorial development environment. I can double click that. There may be multiple streams. In this case, there's only one, but a lot of projects maintain maintenance and historical versions. In this case, there's just the one. The first time that you use Oomph, you may be a little overwhelmed that there's a lot of things you need to configure and choose. So you see we have this notion of showing all the variables. The ones that's showing now are things that I have to specify a value for this particular case. When I say show all variables, you can see things I've configured in the past. So I basically have a rule. It's quite flexible. I don't want to show all of the different flexibilities, but generally people will want all their installations in a certain folder, and then they'll have different names within that folder. So here, that root installation location is in my temp, so I can easily delete them. And we come up with a default folder name for the thing that I'm trying to install.
Can I ask you a question?
Yes.
How is this root, the default value for the root install folder? How it's chosen? Is it the user?
If you've never specified the value at all, it'll default to your user home / Eclipse. But I've changed that, and then it remembers where I would like to have it instead. So we've tried, because this page was so overwhelming, we've tried hard to make sure that every single thing you're prompted for has a default. So you'll generally get to this page, but you can hit next right away. It's probably good to give some thought to where things are ending up on your disk, if that's really where you want them to be. So you specify, like Ika said, some of the things that you decide where should the thing go, which version of the target platform that I want, where are my JREs, or which ones do I want to use. And here at the end we see the tasks that need to be executed to produce this installation. So we can look at the setup itself. Once I've created the installation, we'll review the description for it. But you can see the sort of most important thing is this P2 task to say what's being installed and where to get those things from. So you can see here all of the top level requirements, the things that I need in that installation, and you can see where those things are being installed from. And again, because I've added these redirection tasks, it's installing everything from local update sites on the machine itself. Does some Eclipse INI tasks to set things in your INI. I'll show this in more detail. But the basic idea is you hit finish. It's possible you can disable tasks with the checky marks there, but generally, especially in the beginning, you want them all to run. So at this point, we're on the progress page. It's showing the tasks in action. The task that's currently running is highlighted in bold, and it's basically a log of the activities that are going on. So at this point, it's where it says downloading. It's really getting these artifacts normally from the internet. In my case, it's getting them from a local mirror that's normally on the internet. So it does the full P2 resolution, decides all the things that belong in my profile, and then installs them. Creates a profile definition for it. And that's the longest sort of running part of the installation process. The rest all run very quickly. I had launch automatically checked off, so the IDE launched right away. And now this installer is finished and Eclipse is starting. So you saw that was an extremely fast process. Took less than a minute to create the installation. Even if you're pointing at update sites that are on the internet, you'll generally, the first time, it will take very long to populate your bundle pool. But on subsequent uses of Oomph, the bundle pool will be populated and only the additional updates are downloaded from the internet. So it's very common to be able to create an installation in a minute or 2 minutes. So now the IDE came up and it's fully configured. Unfortunately, my little taskbar has decided not to auto-hide, which is annoying. So you'll see we've created sort of a development environment for this tutorial. It's got an initial project in it. We have documentation in here that will explain the steps that you need to go through. And remember, you can win a spider, a parrot drone for all of the submissions of functional setups that you email to Ika. You'll be entered in a draw, and you can win a prize at the closing session. You have to be present at the closing session to be able to get the prize. So I'll show some of the basic, you're all familiar with Eclipse, so I don't need to show you the basic things that are available in Eclipse. Ike has a suggestion.
Are we sure everybody has the setup now, the environment?
Does anyone still need a stick to get the download onto their machines, or you all have them? I think we're good.
So I mean, did they all install the IDE? Or do they need time for that?
I will go back and get everyone started on the initial steps after I show. So some of the basic things that you'll see are always there when you've installed Oomph. We've tried to minimize the visual footprint, so by default you won't see these toolbar buttons, but everything that I show you on the toolbar buttons are available on the navigate menu. All of the open capabilities are on the navigate menu. So whatever you see here is also directly on the navigate menu. You can prefer to have toolbar access to them. All of the things that you see here are available on the help menu. There's also a perform setup task. So I'll mostly show you what's on the toolbar, but these things are available without the toolbar. So in terms of sort of what artifacts are available and how your installation is configured, that's determined by all of these setup resources. And remember, Ike talked about sort of the main three: the user, the installation, and the workspace. The installation and the workspace here are extremely small. They really don't have any special tasks in them, but if we look closely, it refers to the Mars version of the committers package, because that's the thing that I picked on the first page of the installer. And so everything about setting up this installation is inherited from that product definition. If we look at the workspace, it's a similar sort of concept. You see it's got a reference to the stream, the master stream of the tutorial setup project. So it's possible to go and author setup tasks specifically in these files, and then those tasks will be applied only in this installation or only in this workspace. That's sometimes useful. And what's much more common is that you'll edit things in your user setup, because the tasks that are in this user setup will be applied to every installation that you ever create, and they'll be applied to every workspace that you ever open. So this is the place where you can decide, I want line numbers in my editors, or I don't want line numbers in my editors, and everywhere you will get exactly what you want, rather than every time you create a new workspace, you're configuring those things again. So you see here some of the things it remembers when I get asked for different versions of the JREs. These are the things I've specified. It remembers those things. All of these user preferences I've just talked about are saved under this folder. So we can look at sort of JDT core and see what default preferences I've saved there that will apply to every workspace that I create. And these recorded preferences happen automatically. So I demo this so many times, it's hard to find sometimes a preference that I've not done before, but I think I cleaned this one up. So in general, when you have Oomph installed and you bring up the preferences dialog, you'll see there's a little recording button. When it's red like this, it means it is recording. And whatever I change now, so I changed the always run in background, and I hit OK, you'll see this prompt dialog will come up. And in the beginning, when you haven't used Oomph before, you'll see this dialog a lot, because it's really asking you, you've changed this preference, and is this something you want recorded? Is this setting exactly the setting you want across all of your workspaces? We've actually written some help that describes all of the concepts here. So you really, the first time you run this, you should read that and see what it's trying to tell you. If I uncheck this and I hit OK, it will not record that, and it will never ask you again whether you want to record that. If I leave it checked and I hit OK, it will record it and it will never ask you again. But if you change it, it'll record your changes. So not only are you recording the values, you're training it to stop asking you about it. So for something like line numbers in your editors, if you change it, if you say, yes, record it, I want them, you can go back and change it to get rid of them, and then all of your IDEs, they'll be gone because that preference will be played out. So I'll cancel it so I can demo it again next time. If you hit cancel, it'll just keep asking you forever. So if you're really totally not interested in that, you can turn the button off and then it will not ask you about it anymore. So those are the three basic files that will be there in every installation. In this case, because we've picked a certain project to configure, I can open up that project setup. So we can look at what did I do to create this tutorial setup environment. Well, I decided it's probably good to have quite a bit of heap space. The defaults are generally never enough. I thought it's nice to give a workspace a name. That's something a lot of people don't realize, that there's in the workspace preferences, you can give a workspace a name. So generally, when I start a new workspace, the first thing I do is give it a name. And this is especially nice on the Mac. We've got this Mac badge support. So on the Mac, all these icons for your different installations look the same. If you set the workspace, there'll be a little decorator so you can tell them apart. So in this case, I've set the workspace name. I've got a variable that says where is the tutorial location so that I can make references to things relative to where the tutorial itself is installed. We don't want a target platform for this installation, so I set that to none. And I told it some Oomph things that I wanted installed for this tutorial. And I've got a whole bunch of redirections so that we don't go off to the internet and kill the web server or kill the Wi-Fi around here locally. I put this preference task in. That's why these toolbar buttons show up by default, because I wanted them on by default for this tutorial. I've also done these redirections I showed you earlier that were in the installer's own INI. I make sure that they're also put into this created installations INI. And then I have a bunch of redirections. And if you look, I don't want to go in too much detail, but I've basically redirected the entire Eclipse download site into your local mirror folder. I've downloaded the entire Eclipse mirror or the Eclipse Git site onto local bare clones of those things, and so on. And to get that project into the workspace, I've told it to look in the tutorial location and find this file called tutorial. So if you look in our folders here, there's a file called Oomph tutorial. So I specified that that should be imported into the workspace. So that's the basic sort of structure that we've set up so that you can play with the tutorial. Now, to author your own project setups, that's sort of the goal, why you guys came to this tutorial. You'd like to do all of this automation for your own stuff. And we have nice wizards for that. So it's relatively straightforward. You say File, New, Other, and you create a project setup model. And we have this wizard with a couple of different templates. It defaults to the Eclipse choice. And it's sort of a top-down flow here. So you see, as I type things here, it flows down into other controls, but you can go and change those downstream values independently. So here, I'm going to show doing a project setup for the EMF project. That one is especially easy, but it's also in the project catalog already, so not one of the examples that you guys will try to do. In fact, what makes EMF nice is it follows very nice standard naming patterns. So really, this is literally all I have to do. Yes, I want EMF. My EMF setup is finished. So we can look at the basic pieces that we expect all setups to have. If they're Java projects in general, they're going to need a certain version of the JRE to compile. So here I've said EMF needs Java 1.7. In fact, it only needs Java 1.5, but since so many things need Java 1.7, and it's so hard to get a Java 1.5 from any download site, I've specified 1.7. I've specified a very big heap space. I install a lot of tools, so I like to have a big heap. This is kind of a yucky artifact that we have in all setups. In order to get the package explorer to come up by default showing working sets as the top level items, there's this dialog settings file stored in this place in your workspace. So we copy a file there ahead of time, so when the package explorer comes up, it will show working sets. We have a target platform. So this is something, because we want to be able to compose projects, and all the different projects have their own targets that they're contributing. You kind of need them all to agree on a uniform naming convention and the same variable, so you don't get prompted differently for the target platform of each project. So here we define that variable, but we've only defined a default value for it. So the user will be prompted, but the initial value that they see will be Mars, and in the drop-down they'll see Luna and Kepler and so on as well. We have an empty P2 director task. So these are things that you have to decide for yourself. What additional things does this project need other than the things to make the workspace projects themselves happy? Remember, Ika said when we resolve a target platform, we consider everything in your workspace to see what they need. So in general, these things can be empty. I think I'm actually confusing two concepts here. The P2 director is the tools that I need installed in the workspace. What I was referring to was the target dependencies. And here I'm saying I need EMF in my workspace, and it comes from the Git clone location. I'll show the task in a second. And these are all the different types of target platforms. For EMF itself, I know that EMF needs its own generator tools to be installed. So as sort of later steps in the authoring task, I would say, well, it needs eCore tools because it has diagrams, and it needs EMF's own generator. But that's something you have to discover by knowing the project well. So you see I've got a clone task. Let me show the properties for that guy. So that's a git clone task. And at Eclipse, the clone, there's actually 5 different URIs you can use to clone from a repository, depending on whether it's Git or Gerrit, or you have HTTP access or SSH. So the general idea here is that we specify sort of the base pattern, and from that we can induce choices based on those patterns. And we do that with an annotation that tells us how to induce those choices. So it's pretty straightforward, and generally what the template produces will be functional upfront. And we defined a working set, so I'll show you that in action in a minute. But it's sort of a group of working sets, and each working set you can have a name, and you can specify declaratively what things belong in that working set. So here we've created an AND by default so that it's easy to add children rather than have to create a top-level group. The predicate here is saying this working set should include all of the projects that come from the same repository as the repository that this project is in. So let me show that in action. To make this especially convenient, we've created launchers. There's one per type of platform that you're on. In this case, I'm on Windows 64, so I'm going to launch this installer. So to test this project, you need to get the installer up and running. And when you get to the stage of choosing a project, you want to be able to choose this project that you just wrote. So we'll start with the same as we did before, pick the committers package. And now we'll use drag and drop. So I'll take this project setup that I've defined here, and I'll drag it down to my installer, and I can drop it onto the Eclipse project catalog. So the project catalogs are extensible. They all have this so-called user extension to them, so you can add them as if we've publicly added them to your catalog. So the general idea is we have an Eclipse project catalog, and as Eclipse projects produce setups, they open a Bugzilla and say, oh, our setup is done, please put it in the project catalog. But until then, they can treat it as if it were in that project catalog. And we also have one for GitHub projects. So even if you have a project and it's not an Eclipse open source project, but it's hosted at GitHub, we can add your project definitions to our public catalog. So here I'll double click on EMF, and it only has the one stream. And so now we get to this variables page again. Again, it asks where do you want to create this installation for EMF. And this is what I was talking about earlier, that I have different choices of what kind of clone I can use, whether I want SSH access or anonymous access. In this case, I'll pick the HTTP. And this is just like we saw before for the tutorial setup. It's got the P2 director and sort of the tasks that I was just showing you in the project setup. So an interesting point here is that from these task definitions, some of them can only run in the IDE itself. So when I'm creating the installation, I can't do a git clone. I need to create the installation with git installed, and then I can create a clone in that installation. So you'll see the clone task is not listed here. It's not a so-called bootstrap task. So I can hit finish here. This is the problem I had earlier. Oh, sorry, there's one step I forget, and that you will likely forget as well. In order for all of this offline stuff to work as part of this tutorial, copy this entire folder of tasks and paste it into your project setup. So that's another nice thing that we did with EMF for Oomph, is we have this copy and paste across VMs and across editors. So you'll probably forget that because you saw I did as well. I also have a convenient shortcut here to do my launcher. And we'll go through the same steps. Let me make sure I'll look at so it's smart here when it's suggesting locations, it suggests ones that don't exist yet. So you see it said master 2 because part of what I just executed produced some folders in that location. And let me double check, and again it warns you when you're going to overwrite, and you have to say yes, overwrite. So we're trying to preserve the integrity of things you've already done. And now I can see, oh yeah, good, it's getting all of the updates from my local folder. And then just like you saw before, it does the full resolve. Everything's local, so it's exceedingly fast. And in fact, most of the things have been copied from my mirrors into my bundle pools already, so you see only a couple of downloading things happen, and then the list of all of the things that got installed. So in a moment, I'm going to click dismiss automatically. And so I could go for coffee. If this thing takes an hour, you could go for coffee, and when you come back, the installation will be ready and up and running. You see now it's launching yet another Eclipse. A lot of times the launch takes longer than the install. You're pointing at the clock. Yep, as soon as we get past this point, we will get you started on your own. We're only behind schedule because Ike spoke so long. So you see, as it starts running, oh, it's showing a warning. That can't necessarily be good. Okay, I have an inconsistent INI definition. Let me cancel that. At any point, I can perform the setup tasks again and bring up the installer. And this time the INI task isn't there. I can finish the installation. You won't see this problem in your scenario. It's again the same update problem. Oh, I ran the P2 tasks again, which is not pointful. So that's actually something important to keep in mind for the setups, is don't keep running the P2 tasks. So you'll see all of the tasks that can possibly be executed are listed. There are 2 tasks that are so expensive to check if they're needed that when you do a manual perform, it will always list them. So P2 update can take as long to check whether there's updates there as it does to actually do the update. So we'll finish that. So I would suggest that you all start the installer at this point. You all have the installation on your zip. While this is performing, I'll get you guys started on your own piece. So wherever you've unzipped it, look in the installers folder and find the appropriate installer for your VM and run that guy.
If you have trouble or need help, just raise your hand.
Ike can walk around and help. So when you first come up, it's a clean installation. It will probably come up looking like this. So everyone who wants to follow along and you're not got this working, let Ike know and he'll come around. So if it comes up this way, yeah, my real estate is very small. If it comes up this way, switch it to advanced mode, and then you should see the installer in this state. So make sure to pick the committers package. It's the smallest one. And then on the next page, pick the Oomph tutorial. So notice there's a bunch of ways of sort of controlling what's in the bottom box. Double click will add it and remove it as a convenience. So I won't run this again myself because I have this tutorial set up already. But if anybody needs help, I can come around and help as well. So wave if you're stuck at that point. So the end result, if you walk through those steps in the installer, is that you'll end up with this installation setup. So I'll give you a couple minutes and review what happened with my EMF setup. And then I'll start another one from scratch to show you the basic steps. So you see from the EMF project definition, I ended up with a working set called EMF. All of the EMF dependencies got pulled into the workspace, so we have a bunch of EMF projects. The whole workspace is error-free, so all of the projects are happy. They have the things they need to compile against. If we look at the target platform, we can see that that modular target platform is active. If we open it up, we can see our definition for what should be in that target platform. So you see that this targetlet stuff is fully integrated with PDE. It's not like you need special tools to work with it. It just fits in with the PDE as another type of site. If we look at the content, we can see, yep, there's lots of stuff in there. In fact, the full Eclipse SDK. Okay, so assuming that you're following along and you're going to try one of the other setups, and if for this contest, if you want to do these things over the next day and a half on your spare time and submit the setups, the Spider Parrot drones are pretty cool. I had a look at one of them. They're definitely worth winning. And even if you do these setups for your own projects, I know you're trying to do that, Lorenzo. And yeah, it can be for your own. It doesn't matter. Yeah, I had the instructions and gave his email address, so I'm sure he's going to be spammed by hundreds of people now. And so the steps for the tutorial are in the HTML. I do have detailed steps in here of what I was showing you in the demo of how to create a project file and some of the got-yous. So I'll show you a little bit, give you a hint on some of the ones, and it suggests which ones are good ones to choose because I've tested them and they're relatively easy to make work. So we'll find File, New, Other, and find Setup Project Model under Oomph. And so one of the tricks here is to look closely at what's in the Git clones. So you see these are in the Git folder are all of the local bare clones that we've created of the publicly available Git projects. And in the HTML, I've outlined sort of which ones are relatively straightforward to make work. Let me look in the documentation and I'll find one. Oops. So these ones are relatively straightforward. So and keep in mind that we're going to put your name in once in the draw, once per setup that you send in. So if you send in for 5 projects, you're 5 times more likely to win than if you do only one. So graffiti is actually one of the easier ones, but I'll show GMF runtime. It's a little tricky because the naming conventions for it are quite odd. So if we look at GMF runtime and look at the names, we have to be a little bit careful in our setup task that what we assume the names should be are actually the good ones. So let me do File, New, Setup again. And I'll pick GMF runtime. So initially we want kind of a pretty name, a mixed sort of case name, title case name as the label that the user sees. But this should be sort of a Java package name. So here you see I've changed this to GMF dash runtime because their project name is more like sort of a composite name. And you see here it induces the Git path for the project. I really want to double check that that's exactly what my path looks like in the file system, that it is really gmf dash runtime and that that's the name of the clone. And you see, in fact, it's not quite the right name. Or is it? This is always a tricky part. Some of the projects have very poor naming conventions, in my opinion. Org Eclipse gmf dash runtime. gmf runtime. So it looks correct. If you get it wrong, you'll see later on when you execute it that it doesn't actually work. The git clone task will fail because the location you've specified is wrong. So we'll proceed with that. And we'll follow the same steps. Remember, we have convenient launchers here and this little toolbar. Once you've run it once, it's listed as a favorite. So I picked the committers package again and do the same drag and drop thing. This drag and drop is quite convenient. You can drag links from your email or links from a browser page. So depending on how you've found where a project setup is, you can drag and drop it directly. Failing that, you can use the little plus and you can browse it from your file system, or you can copy and paste the plain text link for the project via this dialog. But the drag and drop is a pretty convenient way.
Did you copy the redirection?
That is a good comment. It's in the tutorial instructions and I always forget. So yes, so to open up the thing that you want to copy, open up the tutorial setup itself. So the Oomph tutorial master. And it has this offline redirections group, which I can copy and then go back to my GMF setup and paste it in there. Thank you for reminding me, that was nice. Be sure to save or it's not very useful. So I've added him, but this wizard's not smart enough to realize I've actually updated the disk after I've read the file. So I will cancel it and run it again. And notice the wizard's quite smart. It remembers your previous choice. And for each product you've installed, it remembers which version you installed. So it has quite a good memory. You can see it remembers the last thing that I installed here from the tutorial. And my GMF runtime is there. You see again it picks pretty reasonable defaults. This GMF pattern looks horrible, but that's how they named it. Let me double check that I've copied the tasks over properly. Oh, scroll bar. Yeah. Okay, then I can hit finish. So the GMF example, all of the examples generally don't work completely out of the box because they don't have nice naming conventions for their root features. Some projects have the root feature is kind of exactly what you'd expect from the project name, and others don't follow such nice patterns. So I'll show the next steps if you get stuck and the setup doesn't work completely. You can test that setup in the installed IDE. Okay, so when it starts executing, everywhere where you have Oomph installed, this startup tasks will be performed when the IDE starts. If you've not used Oomph to configure projects or done anything special, this thing will still run. The preferences that you've recorded will get played out. So you see here it's running and trying to do all the things that we've specified in our setup. And it's made fairly good progress. So you see all of my recorded preferences got set, and it's gotten as far as cloning. So the clone was successfully created. So notice when I select something, it highlights the part of the log associated with that task. But then it got as far as the targets task and failed there. And unfortunately, P2 itself does not provide the most helpful feedback. But we see in the end, it's failed to resolve our root requirements. So in our target task, we said we wanted the GMF runtime.feature.group as our root installable unit. And it couldn't find it because there's no such thing in the git clone. So in order to repair that, we can open up the git clone view and look at what's actually there in the clone that might be a better root requirement. So we can look in the working tree, and the things to look for are features. You can, for these requirements, you could list all 3,000 projects, but that's kind of a pain. Generally, projects have features that require lots of plugins. So if you can identify those few root features, you can limit how many things you're naming explicitly. So if we look through GMF, we can look for something that looks kind of like a root. So you see there's a bunch of features here, and then it's like, there's a runtime feature. But a lot of projects have SDK features. So I will look if GMF has such an SDK feature. And it does. So we see it's got the EMF SDK feature. From here, I can go into the feature.xml and look at what is the ID of that feature. So I find out that's the ID of this feature that we know exists in GMF. I can copy it. I can use open to open up the setup for GMF that this workspace is using. And I can go to my target task and find that requirement that it couldn't resolve, and I want to replace it with one that I know is really in that git clone. So I'll use the properties view for that. Notice this .feature.group thing. That's a naming convention in P2. Bundles have exactly the ID that you'd expect from the manifest. For features, whatever you see in the feature.xml, the IU for it will end in .feature.group. So I've only copied the feature ID itself. So I want to make sure to keep the feature.group. Did I actually copy it? Copy. Notice in the decorations here, you don't see the .feature.group. So our label providers recognize that convention as well and show a different icon for the feature requirements versus the bundle requirements. So that's basically all. I can save that setup, and now I can perform the setup tasks again. And I mentioned this before, when you do a manual perform, some tasks you'll always see there, like the P2 task is there again because you could tell it, go check the Mars update site, see if there's the latest versions of all of the tools. But that's quite expensive. Right now, we're really focused on the targets task. So if there's 100 tasks here, what's quite convenient is double-clicking, deselects all the other ones, selects only that one task. So now I can try the target task again. It always runs in the background in the IDE, but there's a little status control that can bring it to the foreground, and if you want it back in the background, you can toggle it back and forth with this control or the control here. So you see now it was happy, it was able to resolve that requirement and was able to import the projects into the workspace. I didn't execute the working sets tasks, but now I could say, okay, I'm interested in running that task. Wait for my build. But you see my working sets task didn't actually work. I have the working set there, but the projects aren't in it. And that's because if we look at our working set tasks definition, this rule that we had in the same repository as this project, that project we guessed the name wrong. So we can go and fix that and pick a project that really is in the workspace right now, say GMF feature, and save that and perform the tasks again, just the working sets task, and let it finish, and now we see, good. The GMF features are all in the GMF working set. So the working set thing is another very powerful, oops, I did a drag and drop, very powerful thing in Oomph. Sorry. Now there's all kinds of different predicates. So you can say, I want all of the projects that have a feature nature, or all of the projects that are Java projects, a bunch of things. Or once you've defined a working set, you can say, I want this working set to contain the following things, but none of the things that are already in this other working set, these sort of so-called inclusion predicates and exclusion predicates, or everything that has a name that follows a certain pattern. And these things are useful even completely on their own. We have these dynamic working sets preferences, and you can edit them. So even if you don't use Oomph to configure your workspace, you can still create these sort of so-called dynamic working set definitions, so that rather than saying exactly these projects are in these working sets, you can define rules for how your working sets are set up. So that's the basic steps that you need to follow to create a project definition. The templates will create pretty good scaffolding that will get you started, and then you need to follow this sort of pattern. So for GMF, it would definitely need EMF installed. So I would add a requirement to my P2 director to say that I need org Eclipse EMF SDK.feature.group. And if I reran, we can try it, see if that works. So if I ran my task again, I don't know, I've not demoed this before. I don't know if this will actually work. Yeah, it actually did work extremely quickly. So I ran the P2 task. It found where EMF was because it's on the release train and the Mars repository is already on the update site. It found it, installed it in 3 seconds. And of course, when you install new software, you need to restart the IDE. But at this point, the EMF SDK will be installed. So if this is your own projects, normally all the projects I've seen, they have a script for all of the things that needed to be done to set up that project, and that usually includes install find bugs and install. All of these things are very easy to capture. So one trick there, one trick there, if you're trying to figure out how to turn your manual tasks into P2 tasks, if you go to install new software, I'm not sure I can pick, one of my file colon things. You'll see you can always inspect an update site. Oh, is that going to keep clicking on me? You can always inspect an update site with install new software. And if you look at the thing that you're choosing to install, you can always find the ID from it if that stupid dialog would go away. Sorry. Sometimes the error reporter itself is a problem. So I'm trying to get this small enough that I can... let me get rid of the error guy. So from these details, no, sorry, my real estate is too small, but if you look at the things that you're choosing, it'll show the details of that installable unit. And of course, the update site that you've picked here is what you put in your P2 task as an update site, and the ID of that installable unit you show in there. But actually, we have a cool repositories explorer as well. So this is an extremely nice way as well with the repositories explorer. You can put a URL in here. I think it'll be empty at this point, but it shows you a view much like the install new software. And here it'll show, maybe if I copy one of those update sites, no, they're all redirections. Then you can inspect what's in your update site and select the installable unit, and you can drag and drop these things into your target tasks or into your P2 tasks to do those updates. And I think we're kind of out of time. We're going until 11:45, Eike? We're supposed to go to 11:45, right? So we have 15 minutes. So maybe 10 more minutes. Okay, so you had a question.
Yeah, if I rerun the setup tasks,
Yeah.
I check both the P2 director and the target. I noted that when Eclipse restarts, the other tasks are not executed at all.
They normally should be. That would be a bug. So we try to be smart that we do tasks like the P2 tasks very early in the priority list, because the other tasks might actually depend on things being installed. At the point when we restart, we do save a file with the outstanding list of tasks, and when it restarts, it should continue performing the remaining tasks.
The first time it works like that, but
Yeah.
if I change the setup file and I want to test that everything works, then it just executes the P2 tasks and it restarts.
And it keeps doing that in a loop. Normally there should be, but there should normally be no updates. If you've just run a P2 task, there should be no P2 updates. If you run it a minute later, it should be up to date, unless literally some repo was changed. So that could be an artifact of this tutorial environment.
No, I tried it, but I mean the P2 tasks are executed.
Yeah.
It tells me that I need to restart.
If it updated.
I restarted it.
Yeah.
And then the targets tasks or the
Doesn't execute.
tasks are not executed.
It's the is needed is different for the different types of triggers. So the is needed test on an automatic startup checks, is there a target platform definition already there, and was it produced with the current definition? And if that's the case, it doesn't perform. So if your target task has been resolved once already successfully, at automatic startup, it will not run the target task. And also at automatic startup, for the P2 tasks, it looks in your profile definition and says, are the things I've required already there? Are they present in the installation? It doesn't check, are there updates available remotely? So the behavior on manual perform and automatic startup is sort of subtly different for these very expensive update checks. So I generally wouldn't expect a P2 task to run at startup, nor a target task to run at startup, unless there's really missing software or your target has never been resolved before.
So the working sets should perform as well.
They check whether the working sets match the definition. So if that's run before, that won't run again either.
We must finish now. So the time is over. Went quite quick. It was a short tutorial. I can imagine that we didn't cover all questions. We both will be around all the time till tomorrow. When you want to participate in this challenge to win the Paradrone, then please send your setup model to my email address. That is the one on the conference page. If you don't find it there, find me here, I'll give it to you. I have my business cards here. Send it to me, we'll check the setup files for if they are functional. We don't rate them, this one is better than the other one, that is not fair. We just make sure they work. And then at the closing session you can participate in this draw. If you have questions, I guess we could stay another 5 or 10 minutes here.
Yep. And you, if you have multiple successful project setups, we'll put your name in the draw multiple times. So you can improve your odds with multiple successful results. And we want to win it ourselves, so we're going to put our own name in 100 times. Just so you know.
No, we are excluded. That wasn't true. So, thank you for listening. We hope you learned something. We hope you like the Oomph technology. Of course, we continue to improve it, to enhance it. If you have questions, stay a little bit in the room, but you can also post them to our forum. We watch it regularly, answer quickly.
Religiously, even.
Yeah, if you at some point want to become a little bit more active in the project, talk to us. We always look for good committers. Yeah, thank you again, and stay here for a couple minutes if you have questions.